Hi guys. So today we're going to talk about an overview of series. It's really hard to make a flow chart for the thought process that I go through when I look at series because it doesn't really entirely work that way. But we will get to something like that at the end. The first thing you should think when you look at a series is you should look for a set of giveaways. So this is kind of the beginning of our flowchart. And these three things here I've already written are all examples of giveaways. Okay, so when you look, you should just look and say, is this something that I should obviously be comfortable with? So this one, the giveaway in the top left, is the alternation. So here I should do my process for alternating, which is TFD, absolute convergence, alternating series test. Okay, so I should check, does the series diverge? Is the series absolutely convergent? And then I should check if it converges by alternating series test. If I see something like this, whenever I have everything to a power of n, or even more so, everything to a power of n, this tells me that I should be doing root test to get rid of that. So anytime I do this, I will start with root test, which is you take the limit as n goes to infinity of the nth root of the absolute value of a of n. And then this one, the giveaway here is both the factorial and this running product. Both of these tell me that I should be using ratio test. I don't know why I just capitalized ratio but not root. Anyway, so these three things, these don't really fall into my flow chart of what I should be doing because whenever I see them, I immediately think that. So once I've gone through my giveaways, the next thing I should look and say, should I simplify? Okay, so there was an example in the homework that was something like square root of n minus 1 minus square root of n. And so this would be an example of simplifying. Like if I have something like this, I just need to rewrite it because I can't tell what it is right now. If I can't simplify, then the next thing I should think is, so if it looks like geometric or p-series, but isn't quite, I should immediately go to a direct comparison test or a limit comparison test. So anytime I see something that's like the sum of 1 over n minus 5 from n equals 1 to infinity, or 1 over, or like n plus 1 over n cubed plus 1, something like this, these are all things that would be DCT or LCT. So here I would think about what doesn't matter, and then I would go do that series instead, and then argue that the two series have the same behavior using either the direct comparison test or the limit comparison test. If it's not that, then let's see, what else can happen? What else have we talked about? Really the only other thing that's like fairly normal is if what we have is actually integrable, then here I would do the integral tests. So here, this would be stuff that looks like this, where I've got, oh, I don't know, something like this. This is the most common thing. Where my intuition is maybe is going to be a little bit confused here because this ln n here is going to make it more likely to converge, but it was diverging before. So it looks like it's diverging, and then maybe the ln n might tip it over, it might not, but it turns out that I can pull off this integral because this I can u sub ln x. And so this would be an example of something that I would do integral test on. I've also managed to kind of forget basically the first thing that I would do is after I've simplified, I should look at this and just say, do the terms go to 0? And so often, if I'm a little bit suspicious about it, I want to stop and think, do these terms actually go to 0? So if I have something kind of oddball like this, this would say use root test. But if I use root test, it's inconclusive. But it turns out here that if this is an, then the an, the limit as an goes to infinity here is actually e for reasons that we've talked about before. So this diverges by TFD. So after you've simplified, if you aren't sure if something like looks good or not, if you're not seeing something else obvious to do, run TFD and see if that can get you out of it. TFD is also a good place to start. It's a good thing to throw in any place because it's usually not very useful. It doesn't work very often, but when it works, it ends the problem immediately, and so that's a nice thing. The other thing that you want to be ready for, so this is kind of our ridiculous flowchart that has TFD on it twice, which I am okay with. The other thing that you should think about is there are other giveaways that aren't really questions about series. So there's a couple things you should also know how to do. So if it says find the sum, there are one of three things that must happen if it asks you to find the sum. So one, it could diverge. If this is the case, then the sum is, it diverges, that there is no sum. There is no try. Also, what else could happen if it says find the sum? It could be geometric. And then geometric is if absolute value of r is less than 1, then the sum is a over 1 minus r, where a is the first term. This is one thing you could find the sum of, or it could telescope. And this usually means do partial fractions and then do the columns to cancel things out to get Sn, and then you take a limit. And another thing we've talked about is if it asks for anything about the error, we have kind of two main kinds of error questions. You should just remember this sentence: the error is less than the next term. And then look at that lecture for examples of the two things that we could have. And there's also going to be one on the review. So something else we can do is the error is less than the next term. And then other than that, all of these things aside, we also have sequences. So we talked about sequences for this chapter. To find the limit, you take the limit. And then the only trick we need to really remember is if you have a recursion, something like this. I don't even know if this will work. I'm just making this up off the top of my head. What you should do here is if you know it converges, you can take the limit on both sides. You have the limit, I don't know why I just capitalized that L, that shouldn't be capital, as n goes to infinity of a sub n plus 1 equals 1 over the limits on this side too. So you take the limit of both sides, and an plus 1 and an both go to the same thing. They both go to some limit. And then you solve for L from here. Okay, so that's actually pretty much everything we've covered here. It's depressing how little time that took. So you should be ready for using the alternating series test, the ratio test, the root test, the test for divergence, the integral test, and our comparison tests. And be ready for just kind of getting a bank of series where you have to decide what to do. Hopefully that covered most everything. If it didn't, ask me in class on Monday or Wednesday, and we'll talk about other things to do when you see series.